Good day, and welcome to Africa Teen Geeks. This is the STEM Digital School. If you have just joined into this classroom, this is the grade 11 Physical Sciences. It's a grade 11 Physical Sciences. I'm Nonkulele Gomadondo, and I am your teacher for Physical Sciences. This is term 3 assessment. As I've been telling you this whole week, excited and hope that you guys are all well prepared for the assessment. So how this assessment is going to go, you guys are we're going to go through the paper questions that you guys are going to have a chance to do on your own. But thereafter, tomorrow, exactly tomorrow, we're going to be having a revision of the question paper. Okay, so make sure that you are here tomorrow again so that we can do the marking of the question paper. Guys, what's important in this assessment is for you to learn how to test yourself. I know that sometimes it's difficult, especially when you don't understand the question, to refer to a book, but I'd really love you guys to just get into the question paper and see them and try and do it without looking anywhere. Why, guys? So that you guys can test how much you guys know about this chapter or this term 3 work that we've been doing for the past 2 weeks. So the important part is for you guys to understand what is happening. And the only way to do that is by testing yourself. Okay. So please, guys, make sure that you do this paper correctly. Be honest to yourself, trust yourself, and put yourself to that test. This is a self-test. So tomorrow we're going to be marking the work that you guys are going to be doing today. Okay. So the instruction to this paper: when you write on your paper sheet, on your answer sheet, you must write your name. Okay, there's no class, but you can write physical sciences class and space on your answer book. This question paper consists of I think 3 questions. I'm sorry, I wrote 10 there. So you answer all your questions in your answer book, hand in your answer sheet. Okay, this is not going to be necessary. Leave one line between two sub questions. For example, 2.1 and 2.2. You can leave a space between them. You may use a non-programmable calculator. You may use appropriate mathematical instruments, and advise to use the data attached sheet. We do not have a data sheet here, but I believe in you guys that you guys understand your formulas and you know where to get them. Okay, so show all your formula and substitutions in all your calculations. Round off your final numerical answers to a minimum of 2 decimal places, and give brief motivation on your discussions where it is required. Okay, for example, those that you know that are vectors, you need to write your magnitude and direction. Make sure you write neatly and legibly. So the first question here is going to be a small multiple choice. Okay, so please, guys, take pictures as we go along, because I know you're going to test yourself for 45 minutes, but you might not start immediately. Okay, so this is the first question, the multiple choice. Which one of the physical quantities has both magnitude and direction? Okay, so you write that down, but please take screen grabs as I go along on these questions. Okay, which one of the physical quantities has both magnitude and direction? Then we move to number 1.2, which says in the diagram below, an object of mass m is held at rest by a string passing over a frictionless pulley. The mass of the string is negligible. Okay, so the mass of force P on the string is going to be, then you're going to select an answer there. Okay, please make sure you take this picture as we go along. Okay, so are we moving? Are we good to go? Let's move to 1.3. 1.3 says the velocity time graph below shows the motion of the car moving along a straight horizontal line, right? A constant frictional force acts on the car as it moves. Which one of the following statements best describes the magnitude of the force exerted by the car's engine from T0 to T1? From T equals to 0 to T is equals to T2. Okay, are we following through, guys? Now let's move on. And then this is 1.4, the last question in our multiple choice. It says two trolleys A and B of mass M and mass 2M respectively are positioned as shown with a compressed spring between them. If the force exerted by the spring on trolley A is F, then the force exerted by the spring on trolley B is, you pick your answer right there. Okay, so we're good to go. Let's move on to the next problem. Okay, so now we're on question 2, okay? So question 2 says, the first question is 2.1. It says, state Newton's law of universal gravitation in words, okay? And then on number 2.2, it says, a man weighs 800 Newton on the Earth's surface, right? How far above the Earth's surface will his weight reduce after a quarter of his weight on the Earth's surface? Okay? Man weighs 800 Newton on the Earth's surface. How far above the Earth's surface will his weight reduce to a quarter of his weight on the Earth's surface? Okay? So all of that, question 2 counts for 8 marks. I hope these questions are very simple for you as you have studied, but nonetheless, it's all self-test. So now we move to question 3. Question 3 is more about the electrostatics, right? So it says here, two identical small charged spheres, A and B, on isolated stands are placed at a distance x meters apart as indicated on the diagram. The charge on the sphere A is minus 5 times 10 to the power minus 6 coulombs, while the magnitude on charge B is unknown. So it's the electric field pattern around sphere B. Okay. So here is a diagram that illustrates the electric field pattern around sphere B. So I want to know, is sphere B positively or negatively charged? Okay, the stuff that we have done together. Okay. Then you move to 3.2. Guys, please just take a snapshot of these questions as we go along, and you'll do them again when you time yourself properly, okay? So number 3.2 says the charged sphere A and B are allowed to touch and are then moved back to their original position, which is x meters. The charge on each sphere after contact is minus 3 times 10 to the power minus 6 coulomb. Okay. So what they want to know, 3.2.1 says calculate the original charge on sphere B before it made contact with sphere A. Okay. Number 3.2.2 says which of the spheres A or B lost electron upon contact, and give a reason for your answer. Okay, are we getting it? Okay, the aim is to help you concentrate, not to talk too much and end up distracting you, okay? So that's number 3.1 and 3.2. So now let us move to number 4, okay? So question 4, we are still on electrostatics. So what they say here, they say 2-point charges of magnitude plus 5 times 10 minus 6. Oh, sorry. Yes, C and plus 8 are placed at a distance of 0.25 meters apart, right? So here's the 2 charges at a distance apart. So what they want to know in 4.1 is use the Coulomb law to calculate the magnitude of the force of repulsion that the charges exert on each other. Okay, this one is a 3-4 marks. Right? You've done this kind of problem so many times. Okay. And then it says R is F is a point. Okay. So R is a point on the line joining the 2 charges. So it could be here, it could be here, it could be here, it could be there, right? So it's a point anyway. A distance of X meters from the 8 Coulomb charge, right? Such that the net electric field at point R is 0. Okay. So let's see what they want to know. So here it is illustrated. This is our point R at X distance from this charge here. So what they want to know now is 4.2 is define electric field at a point. Okay, what is an electric field at a point? And number 4.3 shows that the distance X is equal to 0.14. So what have they done? The guys have given you guys an answer. So you're gonna have to battle it out until you get that answer. Okay. Basically, they want to calculate the distance. They've given you an answer. So please do try that. Okay. So I'm gonna give you guys a bit of time to go through that. Okay, guys, are you good? Can we move on to the next problem? Okay, so now we move to electromagnetism. Remember that's the chapter that we did that has no calculation, but we only do the theory in this part. Okay, so on 5.1, it says state Faraday's law of electromagnetic induction in words. Okay, so you can state your laws there in words. And then 5.2 says a magnet is dropped vertically downwards through a circular conducting loop as shown below. And an EMF is induced in the coil. So the direction of the induced EM current is viewed from above. Okay. So 5.2.1 says, state the direction of the induced current. Choose from clockwise or anti-clockwise. Okay. Number 5.2.2 says, explain why an EMF is induced across the ends of a coil. Okay, guys, are we good to move on to the next one? I hope you've taken a picture and written it down or um, taken a screen grab. So now we move on to the next one, okay, which is question 6. So question 6 is the application of Ohm's law. It says here, the circuit below consists of 6 ohms and 15 ohms resistor connected in parallel and an unknown resistor R, which is this one over here, in series. So an ammeter, a high resistance voltmeter, an ammeter is this one, a high resistance voltmeter, which is this one, a closed switch, and this is a closed switch, right? And a battery, this is the battery, are connected as shown. The resistance of the battery and wires can be ignored, right? So which means that it says the current is flowing through the wires. Okay. So they say the total power dissipated in the parallel part of the circuit is 50 watts. So remember, guys, which means in this case, we're going to be using that triangle. Remember the triangle of power that we had? We did have a triangle for power as much as we had for current. So you can use the Ohm's law power equations. Okay. So it's 6.1.1. Define the term power. Okay. Determine the term power. And then on number 6.2.2, 6.1.2 says calculate the effective resistance in the parallel combination. Okay, so here you calculate the resistance of the parallel branch, and then maybe you can turn it into a equivalent resistance. Okay, just like we did it yesterday. And then 6.1.3 says calculate the potential difference across resistors in parallel. So you guys understand what potential difference is, right? Potential difference is the same as voltage. Then they might as well have said calculate the voltage across the resistors in parallel. Okay, so are we good to go? Take your time, guys. When you write, you must always take your time, but make sure that you have timed yourself to 45 minutes and make sure that you need to be done by 45 minutes. Because when you're writing school exam, they're not going to give you extra time. They might give you 2 minutes, but once they take the paper, they are going to take that paper. Okay, so you need to start learning to write very effectively. Okay, tomorrow we're going to be doing the revision of this question paper. Okay, the aim is to learn, guys. Why we're doing this is all to prepare you guys for this year, so that by the time this year ends, you are covering all that you're doing. Okay, so let's move on. So continuing to 6.1.4, it says calculate the current through resistor R. Remember, resistor R is the unknown resistor. So we need to calculate the current through resistor R. Okay. So it says thereafter, the switch in the circuit is now open. Okay. Remember before it was closed, so there was current flowing throughout the circuit. So now they've opened the switch. And 6.1.5 says, how will the reading on the voltmeter be influenced? Choose from increase, decrease, or remain the same. Okay. So that is that you guys have to learn. Okay, I'm going to do a quick recap of the paper just to make sure you didn't miss out on any page. So as you can see, this is a very short class because it's just the assessments that we're doing. Okay, so this is our first page of the question paper. Then we move to the second paper. Then this is our third, followed by this one. We had number 3, electrostatics. Then 3.1 to 3.2. Then we had electrostatic continuing on the next, that's question 4. And this is a continuation of question 4. And then we had question 5. Okay. And then we had question 6. And this is the end of our, go through it, guys, and please write it properly. I hope that if you do have problems, just let me know. But nonetheless, we will meet each other tomorrow again when we do the correction of your self-evaluation. Thank you guys so much. And this was our Physical Sciences Grade 11 assessment. Thank you and goodbye.